Hello guys, I do hope that you are having a good day. But before we start with our discussion for today of a new mathematical lesson, please don't forget to hit the subscribe and the notification buttons for more video. Alright, so for today's lesson, we're going to talk about roots of a number. So specifically, we're going to talk about the nth root of a number. So this is really applicable for radicals, or before we talk about radicals, because we are going to apply the concept of the roots of a number there. So before that, so I have already completed the table for you. Alright, so it's really important to be familiar with the perfect square numbers and perfect cube numbers, because they actually play important roles in actually simplifying expressions with rational exponents and radical expressions. So please be familiar with the perfect cube numbers and perfect square numbers. Alright, so let's talk about the nth root of a number. Let a and b be real numbers. So if a squared is equal to b, then a is the square root of b. And if a cube is equal to b, then a is the cube root of b. And if we are pertaining to the root which is more than 3, so we can actually say that we have a raised to the power of n equals b, then a is the nth root of b. What do we mean by that? Let's have the first example, or first set of example. So for letter A, we have to find the square root of 25. Okay, square root of 25 is, of course, 5 based on the table that we had a while back. Alright, so it is 5. But how did we get 5? So as you can see, if we're going to have x, and then we will be squaring x, we will be getting 25. Or, when we say x squared is also equal to x times x, which is simply equal to 25. Now, if you are going to get the answer here, or if you're going to get the square root of 25, of course, you have to extract the root of x squared and extract the root of 25. So if you will be extracting the root of the left side, you also have to do it on the right side. Please remember that. Okay, so that we're not going to change the value of the other side. So if we have square root of x squared, it is simply x, and then square root of 25 is positive negative 5. Okay, alright, so when we are getting the square, there are two possible answers that we're going to get, the positive and the negative values. Alright, so the answer here is positive negative 5. Next, find the cube root of negative 27. So if you're going to use your calculator now, and you will be getting the cube root of negative 27, you will be getting negative 3. So cube root of negative 27 means that we have x cubed equals negative 27, or x times x equals negative 27. Now if we will be extracting the cube root of this, so cube root of x cubed and cube root of negative 27, the answer that we're going to get is x equals negative 3. Why is it negative? Remember this, class. Alright, so if the index of the radical, which is n, is even, and then the radicand, or the one inside the radical symbol, is negative, the answer is undefined. What are the even numbers? So the even numbers are like 2, 4, 6, 8, 10. But if the index of the radical is odd, and then the radicand is negative, you will be getting an answer which is negative. So you have to take note of the difference of the two. Just like what we have answered, cube root of negative 27 is negative 3. Alright, so unlike if the index is even, so this one is odd. If the index is even, the answer that you will going to get if you will be extracting the root is undefined. Take note of that thing. Alright, next, the nth root of a number can be written in a symbol, or in symbol, as nth root of x. It's now the radical. Alright, so n is what we call the index, and then this symbol is what we call the radical sign, and then the one inside the radical sign is the radicand. Alright, so example, if we have the square root of 49, it's now equal to 7. Alright, so if you're going back to the table, 49 is a perfect square. And then if you are going to get the square root of 49, you will be getting an answer which is 7. And then if we have negative square root of 49 is equal to negative 7, take note that the negative symbol is outside the radical sign. That's why if you will be getting negative square root of 49, you will be getting negative 7. Remember the parts of the radical expression. This number on the upper left side of the radical symbol is what we call the index, while the symbol is what we call the radical sign. Then, of course, the one inside the radical sign is what we call the radicand. Take note. Next, finding the nth root of a number. To better understand these properties or concepts, we're going to have examples after this, right? So, for each real number a, nth root of a raised to the power of n is equal to a if n is an odd integer, and nth root of a raised to the power of n is the absolute value of a if n is an even integer. So, to better understand this one, let's have the following examples. So, simplify each radical. Letter A, square root of 81. So, square root of 81, class, if you will be using your calculator, and for all we know, square root of 81, 81 is a perfect square. So, if we will be extracting the root of 81, so we will be getting absolute value of 9. When we say absolute value, class, so the absolute value means it's the distance of the number on the number line. Alright? So, absolute value of 9 is just simply positive 9. So, this will be now your answer. So, have a better understanding of this, we will be using the positive value. Except that, of course, if the radicand is negative and then the index is odd. Let's have letter B. Square root of x raised to the 6th power y square. So, here we can apply the product law of exponents. Take note also that we are going to use the laws of exponents here. So, in talking about radicals. So, square root of x raised to the 6th power y square. So, first thing is that the index that you are seeing right now is 2. Take note that if you are not seeing any index of the radical, automatically it is 2. So, we are only writing 3, 4, 5 if it is, of course, more than 2. Alright? So, but if you are not seeing here, just like here, if square root of 81, we all know that the index here is 2. Alright? So, this time for letter B, we have square root of x raised to the 6th power y square. The first thing is that we have to factor the exponents of x and y. Alright? So, get the common factor of 6 and 2, and it is 2. Alright? So, 6 divided by 2 is 3. This is by applying the product law of exponents. And then, 2 divided by 2 is 1. So, this is simply y, and then the exponent now is outside the grouping symbol. So, we now have square root of x cubed y raised to the power of 2, or x cubed y square. So, if we will be extracting the root, okay, so the answer will be x cubed y. So, this will be now the simplified form of the radical. Okay, now let's have letter C. C, we have cube root of negative 8x raised to the power of 6. Same thing, we're going to do also if what we did with example B. Alright, so for all we know, cube root, negative 8 is a perfect cube. So we can factor out the common factor, which is actually 3. Alright, so we have cube root of, so let's rewrite this. We can also write this as negative 2 cube x raised to the 6th power. Then let us factor out the common factor, which is 3. Alright, so cube root of negative 2, then 3 divided by 3 is 1, and then 6 divided by 3 is 2. Then the 3 was factored out of the grouping symbols. Alright, so it's cube root of negative 2x squared cube is simply negative 2x squared. So we applied the product law of exponents and factoring here. Okay, same as well as B. Okay, so letter D, we have 4th root of 81m raised to the power of 8, y raised to the power of 12. So we are going to do also if what we did with B and C. So the index is 4. Okay, so let's check first is if 81 is a perfect 4th root. So 4th root of 81, if you're going to use your calculators, is 3. If, it means that if we have 3 raised to the 4th power, we will be getting 81. So first thing is we will be writing 81 in an exponential form. So 3 raised to the 4th power, m raised to the 8th power, y raised to the 12th power. Get the common factor of 4, 8, and 12, which is 4. So we're going to have now 4 divided by 4 is 1. So 1 will become the exponent of 3. 8 divided by 4 is 2, and then 12 divided by 4 is 3. Then we have the exponent for outside. Then we can now simplify. So 4th root of 3m squared y cubed raised to the 4th power is simply 3m squared y cubed. This will be the final answer. Alright? So if you do have some questions, you can actually comment down or you can send me a personal message so that we can answer your queries regarding this. Next, fractional exponents. Remember that when we are talking about fractional exponents, this is also the same when we are talking about expressions with rational exponents. It means that the exponent of the term or is fraction. Alright, so let a be any real numbers and n be a positive integer greater than 1, then a raised to the power of 1 over n is nth root of a. So what do we mean by this one? So we can convert expressions with rational exponents to radical expression and vice versa. We can also transform radical expression to expression with rational exponent. To better understand it, if we have the term a raised to the power of m over n, this means that in radical expression, it is nth root of a raised to the power of m. So n now, or the denominator of the fractional exponent, will become the index. And m, which is the numerator of the fractional exponent, will now become your exponent of the radicand. That's why we have now nth root of a raised to the power of m equals nth root of a raised to the power of m. You can also write it like this. We can move out the grouping symbol, the m. Alright? So take note of that. So how are you going to transform expression with rational exponent? Of course, the base of the exponent will become the radicand, and then the denominator of the fraction will become your index, and the numerator of the fraction will become your exponent of the radicand. Okay, take note. So to better understand it, let's answer this example 3. Write each radical as an expression with rational exponent. Alright, so for letter A, we have cube root of x raised to the power of 7. How are we going to simplify this? Alright? So, rather, how are we going to transform this into expression with rational exponent? Of course, we will be copying the radicand, then it will become the base of the exponent. So, x, okay? And then, the exponent of the radicand is your numerator over the denominator, which is the index. So the answer here is x raised to the power of 7/3. Alright? Let's have letter B. For all we know, square root of y cubed has an index of 2. Alright? So we can just simply write this as y raised to the power of 3 over 2. So the index is always on the denominator of the fractional exponent. Let's have letter C. For letter C, we have 4th root of 5. So for all we know, 5 has an exponent of 1. Of course. Now, you copy the base, which is 5, and then the exponent, which is 1, over 4, the index. So this will be now your answer. Now let's have letter D. We can actually group 6 and x, and they have an exponent of 1 and the index of 2. So we can rewrite this as 6x raised to the power of 1 over 2. Alright? So that's how you are going to transform radical expression into expression with rational exponent. Just remember the things that we had while we are answering the examples. Next, how about the other way around? So now, we're going to write each expression with rational exponent in radical form. Alright? So let us begin with A. 8x raised to the power of 1/2. So take note that 8 has an exponent only of 1, and then x raised to the power of 1/2. X is the only base which is raised to the fractional exponent. So therefore, we can actually write this 8. Then the index is 2. We don't need to write that. Square root of x. The exponent of x is 1 and the index is 2. This will be now your answer. Unlike this one, for letter B, we have 8x raised to the power of 1/3. It means that we can actually, we are going to use 8x as the whole radicand because it is grouped. Okay, and it is raised to the fractional exponent. So we're going to have now, okay, the index will be 3 cube root of 8x. Even if you are going to remove the parenthesis, it's fine, all right? So that's the answer, or you can just remove the parenthesis, cube root of 8x. So this will be your answer. How about for letter C? We have 3x plus 1 raised to the power of 5/4. So how are you going to simplify this one? Or how are you going to transform this one into radical expression? So as you can see, the whole binomial is grouped. So we can just simply write this as 4th root of 3x plus 1 raised to the power of 5. This is now your final answer. Okay? So how about letter D? We have 7x raised to the power of 1/2, y raised to the power of 1/3. So our only concern here is x and y. So 1/2 and 1/3 are the exponents. Before we can actually transform this one, take note that we need to actually get the LCD so that we can make the fractional exponents similar fractions. Alright? So we have 1/2 and 1/3. Get the LCD, which is 6 of the two fractions, and then write the new numerator. 6 divided by 2 is 3. 3 times 1 is 3. 6 divided by 3 is 2. 2 times 1 is 2. Now we can write the expression with rational exponent as 7x raised to the power of 3 over 6, y raised to the power of 2 over 6. So as you can see, we now have the same denominator. So therefore, we can transform this as 7 6th root of x raised to the power of 3 y squared. This will be now your answer. Alright? So that's how you are going to transform expression with rational exponent into radical expression. Just remember the things that we had. Okay? Next, let's have example 5. Express in simplest radical form. First is a 8th root of 49. So for 8th root of 49, as you can see, the index is 8. So 49 is not a perfect 8th root. All we can do here is just to simplify this radical. So 49, based on the table that we had a while back, is a perfect square. And square root of 49 is 7. So we can write this as 8th root of 7 squared. They are just the same. Because 7 times 7 is still 49. Alright? So, and then we will transform this one into expression with rational exponent. It will become 7 raised to 2 over 8. Okay? So, 2 over 8 can be simplified into a simple fraction, which will become 7 raised to the power of 1/4. Then, we can actually transform this one into radical expression. It will become 4th root of 7. Okay? And that's already the radical or simplest radical form of 8th root of 49. Okay? Next, let's have letter B. 2x raised to the power of 1/3, y raised to the power of 5 over 6. Okay? So in this case, we can actually apply the things that we've done in the previous example before this slide, alright? So as you can see, our concerns are x and y, or the exponents of x and y. We have 1/3 and 5 over 6. Okay? So we have to make them similar fractions as well. The this common denominator is 6. 6 divided by 3 is 2 times 1 is 2. 6 divided by 6 is 1 times 5 is 5. Alright, so we can write this now as 2x raised to the power of 2 over 6, y raised to the power of 5 over 6. Alright, so then we can simplify this, or we can write this one into radical expression. It is now 2 6th root of x squared y raised to the 5th power. Or simply, you can also rewrite this one in radical form as 2 cube root of x or 6th root of y raised to the 5th power. So, but we prefer this one because it is already written in single radical expression. Alright? So that's how you're going to transform or simplify radical expression. Now, listen. So we're now in the transition. We begin with the expressions with rational exponent, the radicals. Alright? So this time we're going to have radical expressions wherein, okay, here, we're going to simplify radical expressions. So there are two rules that we're going to talk about here in simplifying radical expressions. First rule is product rule of radicals, right? So what is product rule? The operation involved here is multiplication, right? So if a and b are non-negative real numbers, then nth root of a times nth root of b is nth root of ab. So what do we mean by the product rule? Okay, so we mean that if the indices are the same, you can actually multiply the radicand. Just copy the index, which is nth root of a b, or a times b. That's why we call it product rule of radicals. Now, let's have the first example. Simplify each radical. First, a square root of a. 8 rather. Square root of 8, for all we know, is not a perfect square if you're going to base it on the table that we had a while back. So let's talk about the perfect square numbers now. If it is not a perfect square, why we are talking about perfect square? Because the index is 2. Alright? If it is not a perfect square, all we need to do is to get the two factors of 8 wherein 1 is a perfect square. How are we going to do that? Look at the perfect squares numbers on the second column. Alright? Now, based from that, you will divide 8. You will try dividing 8 to the perfect squares number. Then, once you are able to get the exact answer or exact quotient, okay, that means that that is the one of the factors. Alright, here, square root of 8 is that we can actually say that this is also 4 times square root of 4 times 2. So, as you can see, okay, if there's no perfect square, we have to find way on how we can actually get a perfect square number. That's by factoring. So we will be factoring 8, okay, wherein one of the factors is a perfect square, just like the factors that we have now. 4 times 2 is 8, wherein 4 is a perfect square. Therefore, if it is a perfect square, we can move it out now. Square root of 4 is 2 square root of 2. This will be now your answer. You cannot actually move out or extract the root of 2 because it's not a perfect square anymore. That's why it will remain inside the radical symbol. You have to take note of that. Alright? So next, let's have letter B, square root of 75. Same thing. We are talking about square root. Therefore, we are talking about perfect square numbers. Now, 75 is not a perfect square. All we need to do now on the second column of the table a while back, you will be dividing 75. And then once you get an exact answer, of course, that's one of the factors. Alright, so the factors now of 75 are 25 times 3. So as you can see, 25 is a perfect square. And then if you will be dividing 75 divided by 25, you will be getting 3. Alright, so it means that 3 is one of the factors. So since 25 is a perfect square, this is the one that we can extract. Square root of 25 is 5 square root of 3. You cannot extract the root of 3 because it's not a perfect square. Next, let's have letter C, cube root of 81. We are talking about cube root. So therefore, check if the radicand is a perfect cube number. But in this case, 81 is not a perfect cube. What we have to do is the same thing that we did with A and B, wherein we have to factor 81 to get a perfect square or perfect cube number. So, try dividing 81 to all the perfect cube numbers, and then once you get an exact quotient, therefore, those are the factors. Alright? So, in this case, the factors of 81 are cube root of 27 times 3. 27 times 3 is 81, and for all we know, 27 is a perfect cube. Cube root of 27 is simply what? Cube root of 27 is 3 square root of 3. Rather, cube root of 3. Sorry for that. 3, you cannot actually extract the cube root of 3 because it's not a perfect cube. Therefore, your final answer is cube root of, 3 cube root of 3. Alright? Now, let's have letter D, cube root of 104. In this specific example class, same thing. Alright, so 104 is not a perfect cube, so therefore, we have to factor 104 wherein one of the factors is a perfect cube. Okay, so try dividing 104 to all the values there on the third column of the perfect cube numbers. So in that case, we will be having cube root of what? 8 times 13. So 8 is a perfect cube. Alright, so cube root of 8 now is 2 cube root of 13. You cannot actually extract the cube root of 13 because it's not a perfect cube number. Alright, so your final answer here is 2 cube root of 13. Alright, so that's how you're going to simplify if we are talking about simply numbers. How about this set of examples? So for letter A, we have to simplify square root of x raised to the 7th power. Take note of the multiplication law of exponents. If we have x raised to the power of m times, x raised to the power of m times x raised to the power of n, okay, keep the base and then add the exponents. That's the thing that we're going to do here. Alright, so as you can see, square root of x raised to the 7th power, x raised to the 7th power is not a perfect square. So what we have to do, the exponent must be divisible by the index, which is 2. What is the nearest number to 7 wherein it's divisible by 2? Of course, it is now 6. X raised to the 6th power times x. So if we will be applying multiplication law, x raised to the 6th power times x is x raised to the 7th power. So 6 now is divisible by the index 2. 6 divided by 2 is 3. You can now extract the square root of x raised to the 6th power, which is now x cubed square root of x. Why cube? Because 6 divided by 2 is 3. This will be now your answer. Next, letter B, we have square root of 63 x raised to the 9th power, y raised to the 4th power. So how are we going to simplify? We'll begin first with 63. Same thing with the previous examples. We're going to factor 63 wherein one of the factors is a perfect square. So in this case, we have the factors of 63, which are 9 and 7. 9 times 7 is 63. Then 9, x raised to the 9th power, 9, the exponent which is 9 is not divisible by the index 2. So get the nearest number to 9 which is divisible by 2, which is 8, times x times y raised to the 4th power, because the exponent 4 is already divisible by the index 2. So we can now move out the perfect squares, which are 9x raised to the 8th power and y raised to the 4th power. So square root of 9 is 3. Then square root of x raised to the 8th power, 8 divided by 2 is 4. Then 4 divided by 2 is 2. Square root of 7x. You cannot move out 7x because they are not perfect squares. So your answer will be 3x raised to the 4th power y squared square root of 7x. Next, letter C, we have square root of 45x squared y cubed. So this is the thing that we're going to do here. Same as B. So we will be factoring first the whole number. The factors of 45 are what? Wherein one of the factors is a perfect square. So the factors of 45 are 9 and 5. Then 2 is the exponent of x, which is 2, is divisible by the index 2. So we don't have any problem with that. We can just copy. Then y cubed, cube is not, or the 3 is not divisible by 2. So therefore, get the nearest number to 3, which is divisible by 2, which is 2 times y. We can now move out the perfect square numbers, or extract the root of the perfect square numbers, which are 9x squared and y squared. So square root of 9 is 3, square root of x squared is x, square root of y squared is y. Square root of 5y, which are not perfect square. So your answer will be 3xy square root of 5y. So that is the simplest radical form of it. Now let's have letter D. Cube root of 128x raised to the power of 5, y raised to the power of 8. So same thing with what we did with B and C. Okay, we will be factoring first the whole number, which is 128. So factor 128, I get the two factors of 128 where 1 is a perfect cube. Alright, so we have 64 and 2. 64 times 2 is 128. Times x raised to the 5th power, 5 is not divisible by 2, therefore get the nearest number to 5, which is divisible by 3 rather. So it's now x cubed times x squared. Okay, we will be factoring x raised to the 5th power. And then we have y raised to the 6th power times y square, because 6 is the nearest number to 8, which is divisible by 3. Now we can move out the perfect cubes. So cube root of 64 is 4. Then cube root of x cube is x, because 3 divided by 3 is 1. Then cube root of y raised to the 6th power is y square, because 6 divided by 3 is 2. Then what will remain inside are 2x square and then y square. So your final answer will be 4xy square, square root of 2x square y square. This will be now your final answer. Alright, so that's how you are going to apply the product rule of radicals. This time, let's have the quotient rule for radicals or of radicals. So if a is at most 0 and b is greater than 0, then same thing with the product, but this time it's quotient. Nth root of a divided by nth root of b. Okay, we can divide the radicands. Why? Because the index are the same, or the indices are the same. The indices, if the indices are the same, you can just simply divide the radicands. So it can be written as nth root of a over b, or a divided by b. This is only applicable if the indices are the same. That's why it's really important to know on how we can actually make similar radicals. When we see similar radicals, these are radicals with the same index. Let's proceed to our last set of examples. Simplify. We have square root of 8 over square root of 2. So if we will be applying the quotient rule, the index is 2, so therefore we can write this as square root of 8 divided by 2, or 8 over 2. And 8 over 2 is just 4, or square root of 4, and square root of 4 is a perfect square, therefore the answer is 2. As simple as that. Alright, next, b. Cube root of x raised to the power of 10 over cube root of x raised to the power of 7. Same thing, okay, the indices are the same, the index is 3, so we can just write this as a single radical, cube root of x raised to the 10th power over x raised to the 7th power. Now in this case, we can apply the division law of exponents, wherein if we are dividing exponents or powers with the same base, let's say we have x raised to the power of m over x raised to the power of n, we can just simply copy the base and then subtract the exponents. That's the thing that we're going to do here. Alright, so cube root of x raised to the power of 10 minus 7, applying the division law of exponents. Alright, so let's just fix this one. Alright, so 10 minus 7. Okay, now 10 minus 7 is 3. We have now cube root of x cube. So x cube is a perfect cube. We can just extract, and then the final answer that we're going to get is just simply x. Let's have the last two. Simplify. Cube root of 3x raised to the 6th power y raised to the 8th power over cube root of 24x raised to the power of 12y. Alright, so we can combine them, or we can actually divide them as a single radical. Cube root of 3x raised to the power of 6, y raised to the power of 8, over 24x raised to the power of 12y. Then the next thing, class, is that, or guys, we can just simply simplify the fraction 3 over 24, and it is 1 over 8. It is now over 8, and then applying the division law of exponents, we can keep the base and then subtract the exponents. 6 minus 12 for x, and then for y it's 8 minus 1. So y has an exponent of 1, that's why it's 8 minus 1. Then let us simplify. Cube root of, so 6 minus 12 is negative 6, then 8 minus 1 is 7 over 8. Then the next thing is, there's a negative exponent. For negative law of exponents, you just have to simply get the reciprocal of the term with the negative exponent. So this will become cube root of y raised to the 7th power over 8x raised to the 6th power. Then next thing is, we can already simplify, or we can already split this one so that we can simplify. We're now going to have cube root of y raised to the 7th power over cube root of 8x raised to the 6th power. Then cube root of y, factor it, the nearest number, to 7, which is divisible by 3, 6 times y, over cube root of 8 is 2, and then cube root of x raised to the 6th power, 6 divided by 3 is just simply x square. Then simplify the numerator, cube root of y raised to the 6th power is y square, cube root of y over 2x square. This will be now your final answer. Next, let's have letter D. Square root of 9x raised to the 4th power over 16y raised to the 4th power. Okay, so in this case, we can just split it into two. We have square root of 9x raised to the 4th power and square root of 16y raised to the 4th power. This is very easy because all the radicands are perfect squares. Square root of 9 is 3. Square root of x raised to the 4th power is x squared. Over square root of 16 is 4. Then square root of y raised to the 4th power is y squared. Alright, so this will be now your final answer. So that's how you are going to apply the multiplication, or rather the product rule and the quotient rule of radicals. Alright, so they play important roles so that we can easily simplify any radical expression. So for my students, please answer the activity after this, and if you have any questions, you can ask your questions, alright, so on the comment, or you can just simply send me a PM or personal message. Thank you so much for being with me today, and I do hope that you learned a lot, alright. So please don't forget to hit the subscribe button and the notification button below. Thank you so much. This is Teacher Dong, and have a nice day ahead.